you've been looking at slope, and slope is just how steep a line is. And I often think of skiing when I'm thinking about slopes. I mean, that's what they call them as well. So I'm going to draw a line here. And if you were skiing on this, or maybe this is the way you have to get up to get to the top, let's say. Or let's try this one. Maybe this is a slope at a different part of no. Are they parallel? They look pretty parallel. There's one. Yeah. There's the other, let's say. So, if they're parallel, are you going to have more fun on this slope, or are you going to have more fun on this slope? Have a think about that. Pause the video and have a think. Would you rather be on this one and heading down it, or would you rather be on this one and going down the slope? When you've had a think about it, then continue on with the video. It's not going to make a difference. They're the exact same. So if you want to, you could measure the steepness of this. So 1, 2, 3, 4, and let's say this is 1, 2, 3, 4. Okay, now we'd obviously need my axis and carefully done out, and probably graph paper would be excellent for this, but I can see here, you know, it's definitely a positive slope. It's on the increase from left to right. 1, 2, 3, 4 is the run. 1, 2, 3, 4 is the rise. Rise over run, it's got a slope of 1. And, you know, going to have a look at the same here. Here's my, let's say if we look, it doesn't really matter which way we look at it, whether it's this triangle here or this one here. Anyway, that has a rise of 3. That has a run of 3. Slope is 1. So parallel lines have the same slope. So if you ever do any work inside an exam or anywhere and you say, oh, right, well, I found out the slope of this line. It's a -3. Well, if you see a line parallel to that line, don't even, be lazy. Don't even think about doing out the slope of this, working it out mathematically. If they're parallel, they're going to be the same slope. You're going to have the same fun on both of these slopes if you were skiing. I wonder if you could have a think about perpendicular lines. Even if I just draw the most obvious perpendicular lines that, you know, perpendicular just means they're at right angles to each other. So if I get those two lines there, if you were going on a skiing down this, how much fun do you think you'd have? If you were skiing on this one, how much fun do you think you'd have? So pause the video if you want and just have a quick think, and when you're ready, press play on it and you can have a look here and see what happens. So really on this one, it's not, I don't know you're going to have fun, but well, you probably will, but when you get to the bottom, I don't know how you'll end up. You'll be maybe alive, but it will be a huge amount of fun. I mean, that's why people do parachute jumping and all that sort of stuff, or bungee jumping. And then this one, if you're skiing along this, you gonna have any fun? No. They're opposites of each other. So perpendicular lines, this is the way I look at it anyway. have opposite slopes. They're opposite fun to each other. Well, that's how I feel about it anyway. And it's just a way to remember it. It's not, you know, perfect, ideal here. But if you think about it, if I knew the slope of one of my lines, so let's say we know this one is +2. Well, that's a +2/1. What's the complete opposite of a +2/1? And what's the opposite of a plus? It's a minus. What's the opposite of 2/1? 1/2. So if lines are perpendicular to each other, they will have opposite slopes.